Assalamu alaikum, this is MD Abdullah Al-Masumanus, bearing ID 20141046. Here I'll be explaining how OpenRefine works with different algorithms with the sample CSV file. Initially, we open the sample CSV file on a web browser with the OpenRefine application, and here we will be explaining different types of algorithms that are used to clean the data and refine it through OpenRefine. Let's first see what text facet does in the drop-down menu. It's showing us the unique values that this column contains and the number of times each value occurs or their frequency count, and the numeric facet does the same, but in case of text or string values it counts the frequency for numeric values. Then the timeline facet shows us the range of dates for a particular column. We can tune the slider to show us a specific range of dates, and there are also other facets in the drop-down menus, such as word facet, which shows us the frequency count of every verse in the given column and then duplicates the facets. This one is interesting because we click on it and then it's showing us there are no two duplicates. Now let us include those duplicates in the visual representation. Then we can see the number of rows. There are 2 rows which duplicates all of the values in the given file. Using this facet, we can find out if there are any duplicates in our database, and there are also other customized facets, such as facet by error, null, empty string. And for example, if we click on facet by null, it's showing us that there are 986 values which are not null in this column, in language column, and there are 15 values which are null in this language column. These are the rows which doesn't have a value for the language column. But if we click on the facet by empty string, it is showing us that there are no empty string for this language column. So we can infer there is a difference between blank and empty string. Then comes the text filter option. Here we can search for a specific text using regular expressions, which is general regular expressions applied here. Now if you want to search for text for this language, let us write regular expressions, and if we want to find the French language, we can easily filter it out from all of the columns and rows. We can see that it only occurs once in the whole file. The output is correct. Now we can simply use the text facet of the language column. There are also these column operations and transpose operations, which are pretty simple. And then comes the edit cells feature. In this feature, there are some predefined transformations which are commonly used in OpenRefine, like trim and leading and ending white space. Then we convert the whole column to title case, or uppercase or lowercase, to numbers, to dates, text, or null, depending on the standard format. There are some common operations which are predefined in OpenRefine, such as replacing text or smart quotes. These features of OpenRefine have shown pretty simple, just basic conditional operations and loops are applied. Now we shall apply clustering, which is the main principle of our presentation. We split this multi-valued cell and we use double vertical bars as a separator because we can see the author's names are being separated by 2 vertical bars. Now what we have here is the cells have been split into multi-valued cells in each row, and there is only one author name. And now we can easily cluster the author column. And now if we click on cluster and edit, this new window appears before us. As we can see that there are 2 methods of clustering. Under each of these methods, we can find multiple ways to cluster our data with different algorithms. Let's start about knowing how each clustering algorithm works in brief. First of all, let us know what clustering is. Clustering is a way of finding groups of data, different alternative presentations or representation of the same thing in simple words. Datas or values which may be similar or grouped can be found through clustering, and normal string operations cannot find the similarities, but clustering can find it through algorithms and has a huge impact in the domain of unsupervised machine learning. OpenRefine uses two methods of clustering. One is key collision method and the other one is nearest neighbor method. Now what is key collision method? When the hash value of a key map onto an already occupied bucket of the hash table, it is called collision, and this technique is applied in key collision method. With this method, it's possible to cluster different strings based on the fact that their key values or keying functions are similar. Next is the fingerprint keying function. This one's pretty simple. The fingerprint method simply generates the key from a string by following a set of operations in an orderly fashion. Some of the operations are removing the white spaces, converting the characters to lowercase representations, removing the duplicates, and so on. And then there is the n-gram fingerprint method, which creates the key comprising the substrings of length n of a string. And although this method can produce false positives, but using this method, such clusters can be found which the previous normal or regular fingerprint method was unable to find. This method first changes all the characters to their lowercase representations, then removes all the punctuations, white spaces, and control the characters. Then it divides the string into n-grams, which can define through the n-gram size, and stores those n-grams and duplicates grams and then joins them together. We can see that now this Kamal Raja pair of values have been clustered together, which was previously not possible, which in the regular fingerprint method was not able to cluster, but it's possible now. Since we're dividing the string into 2 grams, that's why the difference of an extra space is detected. And while performing operations based on those 2 gram size, then there is these 4 keying functions: metaphone, 3 colon, phonetic dash, and also we should know what a phonetic fingerprint is. We can cluster similar sounding words together, which is useful when people don't know the spelling of a word or misunderstand the punctuation or pronunciation, which is the basic idea. This method can find clusters which is not possible to find with regular and expressions and in in-ground fingerprint methods. And the OpenRefine, there are 4 phonetic fingerprint methods. The first one is Metaphor 3. Metaphor 3 code uses the 6 to 16 consonant based symbols, but is basically when we drop the letters according to their positions in the string and also transform a single letter to a pair of letters, or transform a pair of letters to a single letter. Moreover, it encodes voiced and unvoiced consonants differently. If we look at this method, at the clusters produced by these words actually do sound similar in a few examples, like Jiang Chan Yuan and Zhen Chao Yuan or Jing Yuan. Also, some other examples, we can see the words of the names of the authors sound very similar. This type of phonetic fingerprint methods can actually detect and cluster the similar sounding words. Then there is this column phonetic method. The column matches each letter of the word to a digit between 0 to 8, and sometimes to select the appropriate digit. At most, one adjacent letter can also be used as a context that comes to the Rashmutov method, and this is an improved and redefined version of the sound of the other algorithm. Here the coded names are 6-digit long, and also this algorithm encodes multiple characters n-grams as a single digit. Lastly, we have the Biedermorse method, and this algorithm is identifies languages, then it calculates the exact phonetic value, approximate phonetic value, and the Hebrew phonetic value. Then it finally searches for the matches, so that we can see that it does a pretty good job in finding the author names, and which do sound familiar. There are all the key collision operations. These are all the key collision operations or methods of OpenRefine for clustering. Now let's move on to the nearest neighbor method. But the nearest neighbor method applies any pairs of string that is closer than a certain value, and they cluster it together. That certain value is termed as radius, which simply refers to the distance threshold between two strings. And what is the difference between key collision method and nearest neighbor method? Nearest neighbor method will simply find the key collision methods which are faster, but we have no control over similarity index between strings, whereas the nearest neighbor method provides us with a parameter that is the radius parameter. We can fine-tune to specify the amount of difference between strings up to which we will consider or tolerance against the two types of nearest neighbor methods. One is Levenstein, here neighbor method, and the other one is ppm Levenstein, or edit distance. Edit distance or ppm Levenstein is a way of differentiating two strings based on the numbers of operations that are required to convert a string to another string, such as g, k, and g to k, and the r to n, and so on. ppm means prediction by partial matching. It is good to know that the text compressors work by estimating the information content of a string, so the concatenation of two strings after compression should vary little, but the concatenation of two very different strings should vary a lot in length. And based on this idea, the ppm works. So these are all the clustering methods that OpenRefine apply to clean the data across different platforms of files. And the presentation mainly focuses on the key points of the algorithms, and due to time constraint, I wasn't able to explain in depth of the clustering algorithms. Thank you all for listening throughout my presentation. Assalamu alaikum.